This is 4.6a, graphing rational expressions. So we are graphing today. Your essential question is, how do you graph rational expressions? And it's actually going to be very similar in the next one. We're spending 2 days on it. That's why it's part A and B, because a lot of people have trouble with rational expressions and graphs. So we have our table here. So we're just going to kind of plug in a whole bunch of points and see what our graph ends up looking like. So I will do this. 3, 4, 5, 6, 7. 2, 3, 4, 5. Just trying to make the tick marks as evenly spaced as possible. Then we plug in. So I plug in an x value of 1. So notice my f of x, my equation I'm plugging into is y equals 1 divided by the x value. So 1 divided by 1 is 1. So 1, 1 is one of my points. So I'll use a different color. Okay. Next is 7. 1 divided by 7. So at 7, an x value of positive 7 is at 1/7. It's really, really close, but not on the x-axis. At 1 divided by, so remember, if I have 1 divided by 1/5, division, 1 divided by 1/5, that is 1 times 5/1, which is 5. So at 1/5, an x value of 1/5, so way the heck over here, I'm at 1, 2, 3, 4, 5. Okay. And then we have -1. 1 divided by -1 is -1. So -1, -1, that one's easy. -7 is -1/7. Right there. And finally, -1/5. The same thing's going to happen. It ends up as -5. 5th, -1, 2, 3, 4, 5. Okay, so there we have it. What the heck does this graph look like? Well, if you kind of connect the dots from left to right, on the left side it looks like this. And on the right side it looks like this. And so you can notice that there's 2 lines here where the graph will forever get closer to but never cross. Those are called asymptotes. We're going to have 2 asymptotes, one horizontal and one vertical. And so when we look at our key point, we always have had key points with graphs. We still will. We've had things that are like the vertex, and this time we're going to call it the MVP, the most important or most valuable point. Okay? So, interestingly, the most important point on this graph is where the asymptotes cross. It's not even a point that's graphed, right? We can't have 0 for x. That's undefined. 0 in the denominator is bad. That's what we've been talking about with excluded values and stuff. So 0, 0 isn't even a point on our graph, but it's the most important point because that's where those asymptotes are going to cross, and our whole graph is basically defined by those 2 asymptotes. So notice a few things about this graph. In its present state, it never touches the x or y axis. These are asymptotes. The equation of the horizontal asymptote is y equals 0. Y equals 0 is the x-axis. The equation of the vertical asymptote is x equals 0. So notice horizontal y, vertical x equals. Okay? Interval where it is increasing. So we always move left to right. Notice I'm kind of going down the whole time on both of those graphs as I move left to right. So there is no increasing. These graphs are either always increasing or always decreasing, which you'll see in the next objective when we have negatives. That's when they flip and stuff. But as of right now, they should always be decreasing. But when we define the decreasing, we have to look at the domain. So I'm decreasing from negative infinity, because domains are x values, to 0. That's the first grouping. Negative infinity to 0. And then the second graph starts it back up at 0 and goes to positive infinity. Okay, so notice how we write the domain, which you'll notice that this is going to be the same as the domain. Where it is less than 0, Okay, less than 0 is below the x-axis. So that's just this section right here. So that's from negative infinity to 0. Greater than 0, that's above the x-axis. So that's this section right here. So that's from 0 to infinity. Domain, the x values. So the only x value I'm skipping is 0. So negative infinity to 0. U 0 to positive infinity. And range. Okay. This is the only one where we look at the y values. So down to up. So I'm going down to up, then I skip 0. So it's negative infinity to 0, and then 0 up to infinity. Okay. Use the definition of y-intercept. Make x equals 0 to demonstrate why the y-intercept doesn't exist. Okay, so y equals 1 over x. That's my equation. I'm going to plug in x equals 0. That's how we find a y-intercept. Plug in x equals 0. So y equals 1 over 0. That is undefined because can't have 0 in denominator. Okay. So that's why there's no y-intercept. It ends up being undefined. Use the definition of x-intercept for setting y equals 0. Now, same equation. So 0 equals 1 over x. How we'd solve this is we multiply both sides by x. And notice something weird happens. X times 0 is 0, and that equals 1. This is not true. So therefore, no x-intercept. So we have no y-intercept and no x-intercept. As we shift, that will change. Okay, don't expect there to only ever be that. All right, so we have our general form equation, which I'll write at the top. Y equals A over X minus H plus K, where H is your left-right shift, which should sound very familiar, and your K is your up-down shift. Okay, so in this case, there is no plus K at the end. There's only a thing that's affecting the X directly. This is a right 3 shift. Minus 3 is right 3. Hopefully you know that. Okay, so if I took my key point of 0, 0, my MVP of 0, 0, right, so we said is our key point, and we shift it right 3, I'm at 3, 0. So I'll put that on the graph. 1, 2, 3. Now then, I'm not going to actually draw a point. I'm going to draw a plus sign. You'll see why. But that is my key point. Okay? That is where the asymptotes cross. So that's why it's a plus sign, because these are my asymptotes. Okay? Which asymptote did we move? Well, the horizontal one stayed the same, so we moved the vertical one. Graph still doesn't have asymptotes we can't cross, so it doesn't have an x-intercept, but it does have a y-intercept. We moved this one, so my graph can cross the y-axis somewhere now. Find it and label it on your graph. All right, so we're going to set x equal to 0 into my equation right here. So y equals 1 over 0 minus 3, which is 1 over negative 3. So my y-intercept is 0, negative 1/3. I can graph that. About right there. Oh, I'll use a different color actually, just to clarify what are your asymptotes and what are points. So there we go. State the equation of the horizontal and vertical asymptote. The horizontal stayed the same, that is y equals 0. Horizontals are y equals, vertical lines are x equals. So that's x equals positive 3, because that's the x value that line goes through. State the intervals on where the graph is less than 0 and is greater than 0. Okay, well, I should have done this. Sketch the graph. So I'm going to just sketch the graph. Notice I'm not doing a whole lot. I don't really care about all of the particulars about everything. I care about my x and y intercept and that I'm placing it correctly. Since it's a positive a value, it goes in the bottom left quadrant of the asymptotes and the top right quadrant of the asymptotes. And I just kind of get ever closer to the asymptotes and curve across. And that's all you need to get full points, is your x-intercepts, your y-intercepts. The graphs need to be getting closer and closer to your intercept, or your asymptotes, and they need to be placed in the correct sections. Make sure you do not cross an asymptote ever. State the intervals where it is less than 0, so it's below the x-axis. Well, that's this section right here, but notice it's negative infinity until positive 3 now. So negative infinity, positive 3. State the intervals on the graph is greater than 0. Okay, above the x-axis, that's this section. So that's from positive 3 on to infinity. Remember, we're using x values to denote those values. Okay, last one. Consider h of x equals f of g of x is plugging g into f. So we're going to plug g into f. So h of x equals 1 over, where there's an x, now there's an x plus 4, minus 5, that's the end of that. So we have a left 4, down 5 shift. Okay, so let's put that down there. Left 4, 1, 2, 3, 4, down 5, 1, 2, 3, 4, 5. And we're going to put a plus sign there, and we'll make our asymptotes. There we go. There's my asymptotes. Horizontal is this, which I'm going through a y value of 5. So y equals negative 5, sorry. Going through a y value of negative 5, so y equals negative 5. This is my vertical. This is going through negative 4, x value of negative 4, so x equals negative 4. This time, the answer to asymptotes on both of them is yes. I can cross the x and the y-axis. So we got to find them. Okay. So to find a y-intercept, we set x equal to 0. So using this, it's y equals 1 over 0 plus 4 minus 5, which is 1 over 4 minus 5. We need a common denominator. So denominator 4, so 1 over 4 minus 20 over 4, right? 20 divided by 4 is 5. I'm just rewriting 5. Negative 19 over 4, and then we simplify that. 4 goes into 19 4 times with 3 left over, but it's negative. So negative 4 and 3/4. So I'll plot that point. Negative 4, 1, 2, 3, 4. It's a y-intercept, so 1, 2, 3, 4, and 3, 4. So really, really close to that asymptote, but never crossing it. So my y-intercept is 0, negative 4 and 3/4. X-intercept. Set y equals 0 now. So 0 equals 1 over x plus 4 minus 5. So to do this, we add 5 to both sides. We get 5 equals 1 over x plus 4. We multiply both sides by that denominator. Since there's only 1, that makes it easy. Okay, distribute, so I get 5x plus 20 equals 1, subtract 20, so I get 5x equals negative 19, divide by 5, so I get x equals negative 19 divided by 5. It's close, but it's very different actually. So how many times is 5 going to 19? Well, 3 times, with 4 left over, because 5 times 3 is 15, so I'd have 4 left over. So negative 3 and 4/5, comma 0 is my x-intercept. So I got to place that. 1, 2, 3. Once again, really, really close to the asymptote, but not crossing it, not touching it. Okay, so to answer these last two, whenever they ask about increasing, decreasing, domain, range, above, below, zeros, you need to graph the function. This one's easy. I have to get forever closer, and I have 2 intercepts. Never cross, forever closer. Be careful to never cross your asymptote. This one, however, is a little more difficult, but remember what it looks like. bottom left quadrant of the asymptotes, top right quadrant of the asymptotes, and we have our graph. So where is it increasing? Well, decreasing, decreasing. So in this case, nowhere. Where is it decreasing? Well, it's the whole thing, but we got to define the domain. So at -4 is my x value that I'm skipping right here. So from -infinity to -4, that's the first section. Then my second section starts up at -4 and goes on to infinity. But we skip just the -4 value, and remember, that's how you write it like that. Where is it less than 0? Below the x-axis. Remember, the x-axis is way up here. Most of my graph is below the x-axis. This whole section is, but we have more than that. Where it used to be just this section, we actually have more. Okay, so that whole section, and then right here at my intercept, I cross the x-axis and I'm below it the whole time after that. So my x-intercept is -3 4/5. That's what we just found. At that value, and then on to infinity, I'm also below, less than 0. I'm below the x-axis. So notice where it is. The vast thing, think about covering up just the stuff above it. Everything there we have to define. That's a lot of stuff. Now then, where is it greater than 0? I mean, just this little section right here. That's the only part of the graph right here that's above it. So that's from -4 to my x-intercept. Barely anything. And that's all there is. And once again, we're using domain values. Remember that. State the domain. Well, I'm skipping only the -4x value. So it's actually the same as my decreasing, which it should be for most of the problems you're going to have for homework tonight. And then the range, low to high, I'm skipping a -5y value. So that's -infinity to -5. And then the second part picks up at -5 and goes up on for infinity, positive infinity. And there we have it. So that is graphing. I realize this is tough for some people. We're spending 2 days on it, so make sure you're really practicing these skills now, these basic skills, because we're going to get into a little more complicated things next time. Okay? Remember to answer your essential question and write your 3-sentence summary.